Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Yin Yang Killers by Jonesy. And here are the rules. We have hello, hi. Normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have yin-yang shading, where we color the grid using two colors such that each color forms a single orthogonally connected region and no 2x2 block of cells is entirely one color. So what is an orthogonally connected region? It means a region you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So this is an example of a valid yin-yang shading, because for the shaded region, you can go from any cell in the shaded region to any other cell in the shaded region by going through edges while staying within the region. So for example, to get from here to here, you can just go along these edges and you'll stay within the region to get to that cell. Same with the unshaded region, right? The unshaded region must also be able to go from any cell in that region to any other cell in that region just by going through edges while staying within the region. Now, this is an example of invalid yin-yang shading, because for these unshaded cells now, you cannot go from these cells to any of these cells here by just going through edges while staying within the region. You would have to go through a corner, or you would have to go through an edge and exit the region, which is not allowed. This is also not a valid yin-yang shading, because this 2x2 area is entirely shaded, and that is not allowed. And you couldn't have something like this, because that would not be valid shading, because a valid yin-yang shading, because this 2x2 area is fully unshaded. And those are examples of how yin-yang shading work. The digits along each line sum to the same total. So the digits of all of these digits sum to the same total as this line, the digits on this line. Basically, every line is going to add up to the same sum if you add up the digits along them. And along each line, the yin-yang coloring separates odd and even digits. That is, all odd digits on a line are one color, and all even digits are the other color. Interesting. So for example, these would be, if this was a valid yin-yang shading here, the digits here would have to be 1. You would have to have 1 shading here for that. And so these would be one type of parity. Either there would be odd or even, and this would be a different parity. That would be odd or even. Interesting. And that's for every line. So these would be one shading for that line. There would be one parity. And this would be the other parity for that line. And we have digits separated by a white dot are consecutive. So for example, if this were, say, a 6, this would have to be 5 or 7, because these digits must be consecutive because there's a white dot between them. And the only digits which are consecutive with 6 would be 5 and 7. So that's interesting. So, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So all of these digits on each must add up to the same number, the same total. We have a 5-digit number here. We have a 5-digit number here. The only possibilities that it can add up to then would have to be 15 through 17. So if that were the case, the problem is you can't have these be all the same parity, right? Because if you had them all the same parity, the minimum would be 13579. That adds up to 25, which 2 digits can never add up to. So we have to have a changing of the parity here and a changing of the parity here. That means these, so in yin-yang shading, on the edge of the grid, you can only change colors 0 times or 2 times. And the reason why is if you try to have this, say this shade changed from green to blue to green, and then back to blue. So you can't have odd numbers of changes on the edge of the grid for yin-yang shading, right? You're going to have to change. If this were all green, obviously that would be 0 colors. If you add a blue anywhere, then that necessitates 2 changes of colors for that. And then you can have 4 if you add another blue, which is not in the same set as the other blue. But the problem is, if you have more than 2 changes of color, what happens? How do you orthogonally connect the blue region without breaking apart the green region? And the answer is you cannot. Same with the green region. If you try to orthogonally connect the green region, the blue region is broken up into 2 separate regions, which is not allowed. Because all of one color is all one orthogonally connected region, and all of the other color has to be one orthogonally connected region. Therefore, if you have a change in shading, you can only have 2 at most on the edge of the grid. And we are guaranteed this has to be a change of shading here, and this must be a change of shading somewhere along this line. Therefore, these have to not change shades, and these have to not change shading here. So this is going to be 2 digits which are the same parity. And that adds up to the total that all the lines must sum up to. So the only way that this works, you cannot have 2 evens here. 2 evens would add up to at most 6 and 8, which is 14, which a 5 unique digits can never add up to. The minimum for 5 digits is 1, 2, 3, 4, 5, which is 15. So this must be a 7-9 pair here, adding up to, this is 16, which must be 1, 2, 3, 4, and 6. So that means we have to have 2 of each shading at least. We don't know which, okay, we don't know which shading is which here. This must be green because of the 2x2 area here. This must be blue because of the 2x2 area here. Same with this. This is blue, and then we have 3 blues there, so this must be green. So the thing is, we don't know which shading is which. So this has to be 1, 2, 3, 4, and 6 remaining here to add up to 16, which 7 and 9 add up to. Same with this. Remaining digits in row 1 then have to be 5, 7, 8, 9. So this is 5, 7, 8, 9 here. These have to be the same parity, so it cannot be 8 here. because 8 would have to be with an even parity here, which is not allowed with 5, 7, and 9. So this has to be 5, 7, 9 here. We are guaranteed a 5 is here. That forces this to be 8 there. Remaining digits in row 9 are also 5, 7, 8, 9. Obviously, 8 cannot be there. So this is 5 and 7, which would be 12, plus 4, or 5 and 9 plus 2 there. We're not sure which. This cannot be a 7-9 pair because of a 7-9 pair in the column. Here is 3 unique digits, or 3 digits, which are the same parity. And I think the last one has to be the same parity to add up to an even sum, right? If you have this as the other parity, if this is 3 evens and an odd, that adds up to an odd sum, which 16 is not. If you have 3 odds and an even, that also adds up to an odd sum. So this has to be the same parity, which means this is green. This cannot be green. That's blue and blue here. 2, 4, 6, and 8 never adds up to 16. It adds up to 20. So this must be 1, 3, 5, and 7 adding up to 16 here. That means this can no longer be 7 here. Remaining digits in column 1 have to be all even. So this must be 8, and we have 2, 4, 6 here. So these are both even, which means both of these have to be odd to add up to an even sum. Therefore, this can't be blue because of the 2 by 2 area, so that's green. Another thing about yin-yang shading is if you have a diagonal that's the same shading, the other diagonal cannot be the same shading, and it cannot be 2 of the opposite shading. So let's use this. Let's take a look at it as an example. So say we have the same shading here, then it's 2 by 2 area. It's all shaded, which is not allowed. But if we try to make it all unshaded, the problem is how do you orthogonally connect these regions without breaking apart the other region? And the answer is you cannot. So these are the two deductions you can make if you've studied yin-yang shading. Therefore, since these are both green, this cannot be both blue. One of them has to be blue, one of them has to be green, so therefore this is green because this is blue. Blue has to orthogonally connect out, so it must go that way. Remaining digits here are 2, 4, and 6. Can this actually be 6? 6 and 8 plus 1 and 3 is too big. So this cannot be 6. You could have 8, 4 with 1, 3 here. Right, because 8, 1, 3, 4 add up to 8 plus 8 is 16. Or you could have 8 with 2, 1, 5 here. And we're guaranteed a 1 here. So this is guaranteed to be 1, which means this cannot be 1 here. Where is the 7 in this box? Can't be here, can't be here, can't be here. It has to be here. So that's 7 there. So if these are the odd digits in the sum, it must be 1 here and 3 here. So this cannot be 3. But we don't know if they are. We have 3 digits here trying to add up to 16. You cannot have... It cannot be... So... If we try to make this 2 blues and a green, that's not going to work because the 2 blues would have to be the even cells, the green would have to be the odd cell. And even that, yeah, you can't, these can't, to add up to an even sum, if you have 2 of one and 1 of the other, that's just never going to work. Because 2 of one, well, it would have to always be even. and then the 1 would be odd, so that add up to an odd sum, which is not allowed. So this must be 3 of the same type, and they all have to be even. So then this has to be even, adding up to 16. 8 obviously cannot be here. If you have 2 here, that would force us 2, 4, or 6 here. That would add up to guaranteed 12, which is not allowed. So, and this 2 by 2 area is all blue, so this can't be blue, therefore that's green. Therefore, this cannot be 2, 4, or 6 here. It must be 8, and these must add up to 8 also, so it's a 2, 6 pair. That leaves the remaining digits in box 4 as 4 and 9, which eliminates 4 and 9 in the rest of the column. No 4 here, no 4 here. Okay. This is blue. We cannot have, again, for 4 unique digits, you can't have 3 of one and 1 of the other one. You can't have 4 of the same color, because then that 2 by 2 box would be the same color. So you can't have 4 and 0, because that would break yin yang shading rules. If you can't have 2 and you can't have 3 and 1, because if you have 3 odds and 1 even, that adds up to an odd sum. If you have 3 evens and 1 odd, that also adds up to an odd sum. So we know this must be 2 and 2. You cannot have the 2 be on the same diagonal, because then you would have the deadly pattern here for yin-yang shading. So one of these is blue, which means this has to be green here. This adds up to 16 without 7, 9, or 8. That means 1 through 6. Which means, so 16 plus 24. 16 plus 24 is 40. 45, which is the sum of all the digits in a normal Sudoku, box or row or column, minus 40 is 5. So these two digits must add up to 5. So we cannot have a 6 here. We cannot have a 6 here. So this is guaranteed to be 2 or 4, which means this is guaranteed to be 1 and 3. So the greens here have to be the odd digits. It's because these two must add up to 5. So these have to be some sort of situation here. Anyways, we have a 2-4 pair in column 1, which eliminates 2 and 4 in the rest of the column. So this cannot be 2 or 4 here. It's 6, which means this can't be 6. It's 2 or 3 here. So either this is 1, 5, 2 or 1, 3, 4, and this is 2 or 3 here. That eliminates 2 and 3 in the rest of this box. Also, if greens are even here, this is a 2, so this cannot be 2 there. This has to be a 1, 3 pair, which eliminates 1 and 3 in the rest of the row, and this is blue for the 3 evens. We cannot have 1, 2, or 3 here, or 6, 7, or 8. So we have 4, 5, and 9 there. Okay. So we're guaranteed a 5 and a 6 in this situation. 6 cannot be here, so 6 has to be one of those two digits. So how does this go out? So if this is blue, blue, this is green, and this must go out that way. If this is blue, blue, that's green, green, and this blue, again, must go out this way. So either way, this is guaranteed to be a blue here. To orthogonally connect to the rest of the row. What else do we have? This cannot be all the same color, because if it were, well, it could be green. Maybe. Okay. Hmm. 16, 6. So these add up to 16. This adds up to 16, which means these three digits add up to 13. Oh, this adds up to 16. This adds up to 16. So these three must add up to 13 also. Okay, so what are the possibilities? If you have 2, it's with 5 and 9. 2, 5. Hmm. Um. Hmm. If this were 9, so this adds up to 15. This adds up to 15. Or sorry, 16 and 16. So these three also add up to 13. 8 cannot be either of these digits. So this has to be an odd digit here, which means this has to be even. And you cannot have two evens and an odd adding up to an even sum. So this must be blue. Green has to go that way to orthogonally connect. This must be green also because of the 2x2 area. So again, this adds up to 13. If you have 2 here, it could be with 5 or 9. 13, it would have... 2 and 9 doesn't add up because it would force 2 to be there. So it would have to be 2, 5, and 6 to add up to 13. So 2, 5, and 6. So this can never be 9 because 5 and 9 and 2 add up to 16. If we have 4, 4, 5 doesn't work. It would have to be 4, 7 here, which adds up to... what? 4, 7. So if this is 2, it's 5, 9. And this is 6 to add up to 13, because this adds up to 16. 16 plus 16 is 32. 45 minus 32 is 13. So it would have to be 2, 5, 6 there, which would force this to be a 4, interestingly enough. So we're guaranteed one of these two digits is a 4 in box 3. Or if this is 4, it could be with, it can't be 4, 5, and 5, because that would be a repeat in that box. So it'd have to be 4, 7, 2. Yeah. So we're guaranteed this is a 2 here. So if it's 2, 5, that's 9. So this has to be 4 or 6 here. So this is a 2, 4, 6 triplet here, which eliminates 2, 4, 6 in the rest of the box. That's interesting. If this is 2, that's 5, that's 9. Two, 5, 9. Again, this is 4 or 6, so we're guaranteed a 2 here. We can remove the corner cells here. 2, 5, and 9, or 4, 7, 5 here. So we know 2 has to be one of these digits. If this is 2, 5, and 9, this would be 4. This would be 6. The remaining digits here would have to add up to 10, which is 16 minus 6. So then it would have to be what? No 4, so no 4, 6. No 2, no 9, so it has to be 3, 7 if that were the case. If this is 2, and this is 4, 7, 5, that's 6. 16 minus 2 would have to be, it would have to be 5 and 9. But that's not possible because we already have a 5 here. So if this is 4, 7, 5, this is 2. The problem with that is that would be 6. So we can't have 2, 6, 8 here. But we also can't have 2, 5, 9 because of the 5 in one of these cells. So this cannot be 4, 7, and 2. This must be 6, 2, 5, and 9, which makes this 7 and 9. So this can't be 6, that's 4. No 5 here, no 9 here. That leaves a 1, 8 pair here. That means this can't be 4 here. 6 eliminates 6 being here, so 6 has to be this digit there. This has to be different parity than this, so this must be green, therefore this is blue. Here, this is 3 unique digits adding up to 3 even digits, or 3 digits of the same parity adding up to 16. So it must be all even, which means it's 2, 6, 8 here. That means this can't be 8. This can't be 8, it's 1. Which makes this 8 there. To add up to, so this cannot have 2, 6, and 8. 8 has to be here. So to add up to 17 or 16 here, this must be 8 with 7 and 1, which means this can't be 7, that's 5. This can't be 5, it's 9. So there's no 9 here. Remaining digits then in column 8 are 3, 4, and 9. So we have to have a 2 of one color here and 1 of the other color here. This can't be 1 because of 1 in the box. So if these are odd digits, this can't be 3. It would have to be 1 there. No 4 here because of 4 in the column. So this adds up to 16 without 4 and 8. Remaining digits in box 6. We have 1, 5, and 7. Okay. Which means this can't be 7, that's 3, which means this can't be 3, that's 7. Therefore, this cannot be 3 here because of 3 in the column. So this is 2 or 6, which is an even digit, so this must be 3 even digits here, which means these are odd. So this must be 1, and this must be 3, which makes this 2, 1, and 5 to add up to 8, which with this 8 adds up to 16. Therefore, this is not 5, it's 4. 2 eliminates 2 here, so that's 4, which means this has to be 1 and 4 to add up to 5, which is left over with these digits. So, whereas 1 eliminates 1 here, so this is 5 and 1, that leaves this digit as a 2, so both greens have to be even, and these must both be odd. This can't be 3 because of 3 in the row, so this is 5, which makes that 3. This cannot be 1 or 3 here. This is 2, 4, or 6, so we're guaranteed a 4 here. Remaining digits in column. column 7 or 2, 6, 9. No 2 here because of 2 in the row. Remaining digits in column 9 are 3 and 4. This can't be 4 because of 4 in the row, so this is 3. That's 4. This cannot be 6 here. So 9 and 2 to add up to 16 would have to be with 5. 6 and 9 must add up with 1. So this is guaranteed to be 1 or 5 there. We have a 2, 6 pair in row 5, which eliminates 2 and 6 in the rest of the row. So that leaves this as what? 1, 3, 4, 5, 7, 9. This can't be 1 because of 1 in the column. We have a diagonal here, which is all blue, so therefore this can't be green. It must be blue. This is a 3 by 2 by 2 area, which is 3 blue, so this must be green. So 1 here means this can't be 1. That's 3. Again, 3, 6. These both add up to 8, which adds up to 16. 3 cannot be here. So if this is 9, this would have to be a 4 because there are different parities, because the only even parity here is a 4. But if this is 4 and 9, that would guarantee 3 has to be there, but we have a 3 there already, so that's not possible. So this cannot be 9. This must be 4, which makes that 9 there. So no 9 here. This is an odd parity and cannot be 9 for the same reasoning that we had. So to add up to 16, it has to be 2 odds and an even. And this must be 5 and 7. That eliminates 5 and 7 in the rest of the box. Right, 4 plus 5 plus 7 is 16. Okay, remaining digits of row 8. We have 3, 6, 7, 9 remaining. Remaining digits of row 7. We have 2, 5, 8, 9 remaining. Interesting. These 4 digits add up to 16 without 5 and 7 available. 3 eliminates 3 here. This can't be 7. This can't be 5 because of the 5, 7 pair in the column. Remaining digits, actually, let's do in column 4. We have 2, 4, 6, 8, and 9. So no 2, 6 here because of a 2, 6 pair in the box. This can't be 8 or 9 because of 8 or 9 in the row. So this must be 4. No 4 here. No 4 here. These two add up to 8. With the 8 being there. Cannot be 3, 5, cannot be 2, 6, so it must be 1, 7. Therefore, this is 1 and this is 7. That leaves this as 5 there. 5 can't be here. Where is the 5 in row 7? It has to be here. So this is 5 here. There's no 7 allowed here. No 1 allowed here either. So these have to be opposite than this. Okay, so can this be, if this is green, this is blue, blue. That's fine. If this is blue, so either way, this green has to go out this way. Because if this is blue, this would have to be green, green, because they have to be different parities, so different colors. And therefore, the green has to orthogonally connect out this way. If this is blue, obviously it has to orthogonally connect out this way. So this is green, green here. That leaves this as blue there. Green has to orthogonally connect out that way. These are both the odd digits then. So this has to be 3, and this must be 9, and that must be 4. That eliminates 4 in the rest of the row. Green has to orthogonally connect out there. So we have green and green here, which leaves this as blue to make that work. So this must be 2. which makes that 6. There's no 6 here, no 2 here. This must be 3, 5, and 8 to add up to 16. So this is 8, that's 9, this is 3, because that's the minimum. 9 eliminates 9 here, so it's 6. This can't be 3, 6, or 9, it's 7. 6 eliminates 6 here, so it's 9, which makes this 5 there. So no 5 there. 3 eliminates 3 here, this is 9. So 9 with 3 other digits adding up to 16. 16 minus 9 is 7. It must be 1, 2, and 4. So this must be 1, this must be 2, and 4 here. 9 eliminates 9 here, so that's 8. 4 eliminates 4 here, so that's 2 and 4. 9 is consecutive with 8, so that's 8. No 2 or 8 here, it's 6. No 3 or 5 here, it's 1. So no 1 here. 1 eliminates 1 here, so that's 7, which makes this not 7, that's 1. 7 eliminates 7 here, so that's 5 and 7 there. 6 eliminates 6 here, so that's 2, which makes this 8. 2 makes this not 2, so that's 6 and 2. 5 eliminates 5 here, so it's 3 and 5. 2 eliminates 2 here, so it's 6 and 2. These are different shadings than this. This must be green. So this is green and green. This is blue. We have a 2 by 2 that's all blue, so this can't be blue. That's green. We have a 2 by 2 that's all green, so this must be blue. So these have to be the same parity, so we have blue and blue. Green has to orthogonally connect out. These are both blue, so these must both be green. We have a 2 by 2 area that has 3 greens, so this must be blue. This is a diagonal that's all green, so this has to be green. 2 by 2 area that has 3 greens, so this is blue. And 2 by 2 area that's all green, so that must be blue. These are different shadings. Diagonal that's all blue, so this can't be green, so that's blue. 2 by 2 that's all blue, so this can't be blue, that's green. So odds are greens here, which means evens is blue. We have to orthogonally connect the greens, and that's it. And so this is the shading. This must be 9. That leaves this as 3 and this as a 6. And that's the solution to this puzzle. Not too bad. Fairly straightforward about the yin-yang shading, plus the digits summing up to the same, or the lines all summing up to the same sum is a fairly big restriction. With a lot of implications here. Just a pretty cool puzzle all overall. Flowed very well throughout. It was not, the logic wasn't too bad. If you have experience with yin-yang shading, then it's probably going to be probably more along the easy dynamic. But if you don't, it's probably going to be definitely more challenging. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.